Well, hello, young statisticians. This week we're going to move into a new kind of unit or topic. It has to do with things we call scatter plots and lines of best fit and correlation and a few other big words I'll be throwing at you over the next few weeks. So I wanted to kind of preview assignment number 7 with you, kind of give you some ideas on how to navigate it. So once you get to the assignment 7 document, it comes in 3 parts, and I want to focus on part A with you, which talks about scatter plots. Now, one thing is you'll want to make a copy of the document because you're going to hopefully do all your work on the Google document this week and then submit that to Schoology. So make sure you make a copy so that you have something that you can go in and edit. Once you've made a copy, we'll kind of look at the directions here for part A. For each of the following scenarios, use the stats applet, least squares regression. And this is a link, by the way. It'll take you to least squares regression applet. Make a scatter plot showing the relationship between the given variables. Copy the scatter plot, paste it onto your copy of this document. Then describe the distribution. And there's a whole bunch of descriptors, which I'm going to show you how to decipher. And so then here's an actual link to where the data itself is. So I'm going to kind of do this first one, forearm length versus foot length, just to kind of illustrate what I'm looking for. So first of all, I'm going to go to the assignment data. Let's see, here we go, stats, assignment data. And this should take you to a spreadsheet where I've kind of organized the data into different groups. I get different tabs here. There's some survey data, boys' height versus weight, state populations, a problem about airline bags and on-time arrival, and some SAT math scores. So this is where you'll find all the data for assignment 7. So now our first task was to make a scatter plot showing the relationship between forearm length and foot length. And this is the data that you gave me at the beginning of the year. So there's like 55 students. So what I'm going to show first is kind of how we would do it sort of at a basic level. So what I did, and this took about 10 or 15 minutes, is I went through and I plotted all the individual outcomes right here. And there should be about 55 dots here. So for example, one student had a forearm length of 10 inches and they had a foot length of 7 inches. Another student had a forearm length of 11 inches and they had a foot length of 8 inches. Here I had 4 students who with an 11-inch forearm and about a 10-inch foot length. And so altogether this is 55 dots, or it should be 55 dots. We call this a scatter plot, and it's meant to show the relationship in what we call bivariate data. It's because you have 2 different variables here. You have forearm length, and you've got foot length. So when there's 2 variables that you're kind of comparing, we call that bivariate data. Up until this point, you've been working what's called univariate data, where there's only a single variable that you made into like a box plot or a histogram or a dot plot. That's what you do with univariate data. And we're now talking about when you have bivariate data. So then the next phase is, okay, well, how do you kind of describe the relationship that seems to exist between foot length and forearm length? So let's kind of break it down into some terms here. I'm going to go ahead and slide the paper up a bit and I'll come back to the graph as I need it. So first of all, we have what are called cases, and this should be pretty familiar to you. Cases are the people or the things that provide the responses. In other words, all these forearm lengths and foot lengths, where did we get them? Well, those were provided by you. So the cases in this would be the 55 students. That's where we got the information from. Let me zoom in and make that a little bigger. Okay. Now the variables, okay, what was it we measured in these 55 students? Well, we measured the forearm length. And then we also measured the foot length, okay, and so that's the other variable. foot length. And these were both measured in inches. So just as it's been before, cases and variables, these both happen to be measurement or quantitative variables. They're not categorical, and they're certainly not binary because there's a whole bunch of different numbers we could have written down in our response. So the next phase is to talk about the association between the variables. Now there's a few little notes here. An association, there's no context. We're not going to talk about people or forearm lengths or any of that stuff. It has no context in an association. And we try to capture three things: the shape, the strength, and the direction. So let's talk about these one at a time here. So in terms of shape, what we're looking for is this pattern we see here linear or is it curved? Okay, now it's not going to be a perfect line or a perfect curve, but if you were to kind of look at this, you kind of see this kind of like strip of data right here. That looks to be like a linear pattern or a linear path. Curved path, the dots would really start to really show some kind of curvature, and you really don't see that here. So this, I would say, is a pretty much linear in terms of its shape. So for association, I'm going to put linear. And again, the other option is curved, but this one is linear. You then talk about the strength. And the strength has to do with how tight the formation is. If all the dots were, really lined up really well in a nice tight formation, we would say that is a strong association. If the dots are just all over the place and they're not really in much of a linear formation, we would call that a weak association. This one is kind of in between because it's not super tight, but it's not like all over the place either. You could kind of sense a bit of a linear trend. We'd probably call this a moderate association. So linear, moderate. In terms of strength. Now again, the other options are weak and strong. Okay, so keep those in mind. And finally, we have direction. What we're looking for is, do things kind of go in a positive or negative direction? And it has a lot to do with the slope. This right here, this seems to be exhibiting kind of positive slope, so we'd call that positive direction. If all your dots were going this way, we would call that a negative direction or a negative slope. So this one has kind of a positive direction to it. So we would say, in terms of association, linear, moderate, and positive. And in the order of these words doesn't really matter. Some people like to do the strength and then the shape and then the direction. It doesn't really matter. Okay, so you might see, well, it's moderate, linear, and positive. That is fine if you want to put things in that order. So again, you talk about three things: shape, strength, and direction, and there's no context. You're not talking about the people. You're not referring to forearm or foot length. We save the context for what we call the trend. Okay, the trend is where you want to use context, and it'll be something like this. We have students with a variety of different forearm lengths, and what we want to say is, well, those students who have longer forearms, okay, tend to also have the longer foot lengths. Okay, and you'll notice students with the shorter forearm lengths tend to have the shorter foot lengths. So let's write that down a bit more formally. Okay. Students with longer, let's say, forearms tend to, and that's very important to say tend to, because I'm sure there's some exceptions to this. We don't want to say this is like a universal rule for every single kid, but there's that tendency. Students with longer forearms tend to have longer feet. Or you could say students with shorter forearms tend to have shorter feet. And that's very typical of a positive direction. Now, there may be times when if the dots were perhaps running downhill, you might say, oh, students with longer forearms tended to have shorter foot length. Okay, and that would be in the case of if we had a negative direction. Okay, so again, this has context. Okay, students with longer forearms tend to have longer feet. We call that the trend. The next item you talk about is what's called generalization, meaning that let's say this was a sample of 55 students. Could this trend apply to a larger group of people? In other words, could we generalize from the 55 students who took the survey to maybe say, okay, this is a fairly typical pattern for all students at Piedmont High School, or perhaps all students in California. And that's what we mean by generalize. If you could kind of take this and say, well, could we generalize this pattern to a larger group? And you have to kind of ask yourself, well, okay, well, where did these people come from? Where did these 55 students come from? They came from Piedmont High School. They generally came from the senior class. So maybe you can generalize to the entire senior class. Maybe you can generalize to Piedmont High School. I don't know if you would want to generalize to a bigger population because, frankly, this is not really representing, all California kids. All these are all kind of Piedmont High and Millennium High School kids. So if we're going to generalize, okay, we could probably generalize to perhaps all PHS, MHS seniors, or we can maybe generalize to all PHS students. I'm not sure it would be good to kind of extrapolate beyond that. So we could probably generalize to those two populations. There are times when you really can't generalize at all and just say, nope, that's it. Everything you're seeing, all the possible data there. I can't really generalize beyond that. Okay, and then the last part is are there plausible explanations for what we're seeing here? In other words, does one variable cause the other one to happen? Or is there maybe what we call a lurking variable, a third variable that's kind of in control of both situations? So what that would look like is we'd have to ask ourselves to say, well, does having a longer forearm cause you to have a bigger foot? Does a shorter forearm cause you to have a smaller foot? Is one kind of dependent upon the other? Or is there something else that's kind of in control of the situation? You wonder, well, why do people with longer forearms have bigger feet? And you think about that a little bit and you go, well, it's probably something in their genetics that as they grow, as they get older, their forearms get longer and their feet get longer, up until a point, mind you. So this one, I think, is probably more a case of a lurking variable. In other words, just because it's like if you were to stretch out your forearms, your feet aren't automatically going to stretch along with them. There's a third variable that's kind of in control. So this is probably not a cause and effect relationship. It's probably the case of a lurking variable. So we could probably say there might be some lurking variables like lurking variables. Maybe it's genetics. Or maybe it's kind of like your age. Okay? Something in that area that's probably sort of controlling your the length of the forearms and length of the feet kind of at the same time. There will be some ones that are cause and effect, where one is definitely the cause of the other, where increasing one will force the other one to increase because there's sort of a causation going on. So we'll talk more about this as the weeks go by, but I'll be interested to see what you write on here. So that's some notes on kind of how to kind of describe the association. So now let's get back to how you do this electronically, because doing this by hand takes a lot of work. So let me turn that off. Okay, so how do we do this electronically? Well, one thing you want to do is you want to just go to your spreadsheet, and if you highlight, and we're going to copy all that data. So I'll copy. Okay, so then I'm going to go back to my document. And here I've also put a link to the least squares regression applet to quantitative variables. And so you'll come to this, this applet. And so I'm going to go ahead and clear out the data that's already there. I'm going to paste. Just want to make sure I pasted all the data in. Okay, forearm and foot. Then I'm going to use the data. And so this produces a scatter plot, and that looks pretty similar to the one I drew by hand. Now there's all kinds of things you can do on here. If you're interested, we can have it make the line of best fit for us. We could find what's called the correlation value. Those are both very useful statistics. There are a few other things in here that are kind of neat to play with if you have time and interest. But what I'm mostly interested in is, can you kind of just basically copy this image and paste it onto your document. So I'm going to see if I can do this. I'm on a Mac, so I have a little different way. I'm going to kind of take a screenshot if I can of this. Okay. Okay, so now I just got to go find it. So I want to paste it onto the document. So here's the document, and everyone's computer is a little different. For me, when I get a screenshot, I have to I can grab it over here, and I want to paste it right underneath forearm length versus foot length. And so this will paste it right in here. And so then I can, right below that, I can start typing in, okay, cases, the 55 students. Let's see, variables would be, was it forearm length, and foot length, and so on. And I need to work on my typing here. Never learned to type real well, so I get my letters switched on me. Okay, so variables. And you just kind of keep typing those in, and then once you're done, you can then go to the next one. And if you want to maybe make these bold so they stand out a little bit, you can kind of format your paper in the way that suits you. So I'm looking for, there is a scatter plot, and then kind of you're describing the relationship. And you're going to do that for several things: foot length versus states, average height versus average weight, so on. And as you keep adding stuff, this will kind of push things further down on the paper. Keep in mind as you go along, eventually you'll get where part B is, which is a different kind of problem. But everything you should be on this document. So it's a pretty straightforward task. You do not have to make the scatter plots by hand. Let the applet do it. And I'm more interested in kind of you typing up the interpretation. So hopefully this gives you some guidance on how to get through assignment 7. Thank you for watching.